And it is my pleasure to invite the next speaker, is Pornpimon Boriwan, from Nareswan University, which is asked to take the microphone. Thank you.
Good afternoon, ladies and gentlemen.
Good afternoon also in Romania. So it's
Good afternoon, ladies and gentlemen. My name is Pornpimon Boriwan. I am PhD student from Nareswan University, and my advisor is Professor Dr. Narin Petrot. And today I am going to present in a topic on the properties of the lexicographic Tolerable robust solutions for uncertain multi-objective optimizations problems. And in this work, I am joined with Professor Dr. Kuroiwa, Daishi Kuroiwa, and Professor Dr. Narin Petrot. Sorry. And there are two sections in this talk. The first one is about the notations, and the second one is about the lexicographic Tolerable robust solutions concept. And why we want to study in multi-objective robust optimizations, this is because there are much evidence that most of real-world problems are of multifaces, and the input data are usually imprecise. It may be because of the measurement errors or is involving the future unknown data. So these factors can limit the abilities of the methods in optimizations to find optimal solutions in a variety of real-world applications. And multi-objective robust optimizations is one way to deal with the multi-objective problem structure, which is involving with uncertain input data, because the aim of this method is to find a solution that are practical and have a good qualities for all possible realizations of the uncertain input data. And this is the notation which we will use in this talk. And this is the relations which will be concerned in this talk. That is, for any vectors x and y in a vector space Rp, these four relations defined by this one. And by using the inverse inequality analogously, we will define the cone Rp with respect to its relations by this way. And we now recall the definitions of multi-objective optimizations problems. A multi-objective optimization problems MP is a problem dealing with minimizing a vector value objective function f from Rn to Rp over some constant, which is represented as the problem 1.1. And this is some well-known solutions concept for this type of problems. A feasible solution X is called an efficient solution or Pareto solution if there is no another X-prime in a feasible set X, such that satisfy the relations 1.2, and by replacing these relations with these relations, a solution X is called strictly efficient solutions, and if replacing these relations with these relations, a solution X is called a weakly efficient solution. And moreover, this is one more definitions of a solutions in this type of problems. A feasible solution X is called lexicographic solutions if there is no another X-primes in a feasible set X such that satisfy this relation. And now we are in a position of the problem which we want to focus on. That is the problem of uncertain multi-objective optimizations. An uncertain multi-objective optimization problems MPU is given as a family of a deterministic multi-objective optimizations problems MPS, whereas for each H in U, the problem MPS is defined by the problem 1.4. And this is some definitions of a solutions concept in this type of problems. In 2014, ERGOS propose a solutions concept for the uncertain multi-criteria optimizations problems, which we call min-max robustness. And before we are going to see a formal definitions of these solutions concept, we will introduce the following notations. That is, for each feasible solution X in this set, the set of all possible objective vector under all scenarios will be denoted by these notations, and this is the formal definitions of min-max robustness. A feasible solution X half is called a min-max robust efficient if there is no another X prime in a feasible set X which is not X half such that satisfies these relations, and by replacing this cone with these cones, a feasible solution X half is called a min-max robustically efficient solutions, and if we replacing this cone by this cone, a feasible solution X half is called min-max robust weakly efficient solution. And motivated by the idea of lexicographic solutions and min-max robustness, we will now introduce a new robust solutions concept. And before we are going to present our solution concept, we will recall the definitions of ordering a value in non-increasing ways. That is the definitions of sort functions. A sort function is a function mapping from Rp to Rp. Thus, reorder the components of each vector on Rp, which is represented by this way. And from now on, we let uncertainty set U be a finite set of possible scenarios, and a vector X is a mapping from this set to this set. So, for each X which belongs to this set and I belong to this set, the notation Cix will be used to denote a vector which is composed of the I components of the objective functions for a feasible solution X under scenario Hj for all j. And then, subsequently, we will put the notation C half Ix to stand for the vector of sort function of sort vectors of a vector Cix. And for more convenience, we will denote this vector by these notations. So, according to the above notations from 2.3 to 2.9, the worst performance vectors can be determined as 2.6. And moreover, for any subset A of Rp, by using the relations lexicographic orders, the infimum of a set A with respect to the lexicographic orders is denoted by these notations will be defined by these relations. And we now introduce the concept of reference point of the problems. That is, a vector C half star in this set is called the reference point of the problem MPUs if for each j, C half star j is defined by the infimum of this set with respect to the lexicographic orders. And we now present the solutions concept. And we now present our proposed solutions concept. That is, let MPU be an uncertain multi-objective optimizations problems with the reference point C half. So, for each alphas which belong to this set, the set of lexicographic tolerable robust solutions with respect to the tangential alphas is the intersections of the set Aj alpha j's, whereas Aj alpha j defined by this set, and we will denote this set by the notations of LRS alpha. So, in this work, we now present and interpret the important properties of the solution set of a lexicographic tolerable robust solution as the following. And this is the first one. The first one is the property of the dominant of a solution set. Let alpha be a vector in this set and x is an element in this set. If there is y in a feasible set satisfy these relations, Then we must have that such Y must belong to the solution set LIS alphas. And what is the meaning of this property? The meaning is there is no feasible solutions in a feasible set X which is dominates a robust solutions under all scenarios. It must be a robust solution. The next property is the property of monotonicity. That is, for any alphas and betas in this set, such that for each j, alpha j less than or equal to beta j, then we have these facts. This means that if it is a lexicographic tolerable robust solutions with respect to the small numbers of the torrent ratio, it will be functions correctly with the larger torrent ratio value. And before we are going to the next properties, we will introduce the following binary relations. That is, let such and such prime be a vector in Rp. The relation which will be denoted by these notations is defined by this way. And this is the property of non-preference of the solution set. That is, if X is an element in the set LIS alphas and such is not, we then have these facts. These facts mean that there is no preferable solutions being outside the solution set LIS alphas with respect to the operators worst performance vectors and torrent ratio alphas. And this is the last one. The last one is the property of the stabilities of the solution set. That is, for any X and X prime in a solution set LIS alphas, we then have these facts. And the meanings of this property is there is no preferable solutions among elements in the solution set LIS alphas by considering the preference defined by these relations. And this is the links between the lexicographic tolerable robust solutions and the minimax robust efficient solution, which was introduced by Eckert. The statements of this link is, if X is an element in the set A1 zeros, whereas A1 zero defined by this set, then such X half must be a robust weakly efficient solution for the problem MPUs. And by adding more sufficient conditions on the assumptions on the previous theorems, we then have these results. That is, let alpha be a vector in this set and say S and assess A1 alpha 1 is a singleton set, whereas set A1 alpha 1 defined by this set, then X half must be a minimax robustically efficient solution for the problem MPU. And before we are going to finish this talk, we will present a small example but important. Consider the information in a table 1. Then, according to the definitions of the set A1 alpha 1, we will obtain a set A1 alpha 1 is this set for all alpha 1 in a cones Rp. And moreover, if, sorry, I cannot see. Sorry. Yeah, I'm so sorry. And according to the definitions of min-max robustness, which was introduced by Eckert, the solution set of min-max robust efficiency is X1 and X4. This means that for any choice of alpha 1 in this cone, a set A1 alpha 1 does not a subset of a set of efficient solution of a set of minimax robust efficiencies. And moreover, According to the definitions of lexicographic solutions, the solution with respect to the smallest torrent ratio is X3. And this means that by relying on the solution concept of lexicographic tolerable robust solutions and min-max robust efficiency solutions, the solution set obtained by these two concepts can be extremely different. And this is what we obtain from this talk. That's it. The properties of the solution sets of the lexicographic tolerable robust solutions and a technique for computing an element of min-max robust efficient solutions by using the lexicographic tolerable robust solutions ideas. And this all. Thank you so much for your attention.
Thank you. Thank you for your nice presentation for the very interesting topic. You are exactly sharp in time, so congratulations for both presentation and being exactly fixing the allocated time. If there are any questions or comments, please. No, in this case, we continue with the next speaker. Thank you again, Pornpimon, for your presentation. Very
Thank
nice,
you so much.
very well organized.